The most famous chart in science might be impossible to own. At least, that's what I discovered when I tried to collect every element on the periodic table. There are 118 known elements. My mission sounded simple: find them, buy them, borrow them, or somehow track them down in the real world. But before I even started, everyone told me the same thing. Impossible. Some guessed I could find 20. Others thought maybe 30. One person warned that parts of the table could literally kill me. And that's when the challenge became interesting. To make things worse, I made a deal. If I collected fewer than 80 elements, I'd have to eat an egg and cheese sandwich. That might not sound scary, but trust me, it was motivation. So I grabbed a budget, found a chemistry expert, and asked a simple question. Can an ordinary person build a real periodic table? The answer surprised me. Not exactly, but maybe sort of. Many elements exist inside everyday objects. Some are hiding in batteries. Others are inside bikes, toothpaste, balloons, soil, electronics, and even the air around us. Suddenly, the impossible challenge didn't seem impossible anymore. Hydrogen? Easy. Carbon and oxygen? Everywhere. Lithium? Batteries. Neon? Signs. One by one, the collection started growing. And here's the strange part. The deeper I went, the less the periodic table looked like a science chart. It started looking like a treasure map. Every element had a story. Every discovery unlocked another mystery. And I was moving faster than anyone expected. But that confidence wouldn't last for long. At first, collecting elements felt almost unfairly easy. Rows disappeared from my checklist. The budget stayed under control. Everything was working. Then I discovered the secret hidden inside the periodic table. A secret that changed everything. Back in 1869, a scientist named Dmitry Mendeleev created a version of the table that looked incomplete. There were gaps everywhere. But those gaps weren't mistakes. They were predictions. Mendeleev looked at the patterns and confidently claimed that entirely unknown elements existed. Years later, scientists found them almost exactly where he said they would be. Think about that. He discovered things before they existed. Or at least before anyone knew they existed. And this is where it gets weird. The same table that helped predict the future was now fighting against my challenge. As I moved into the later rows, elements became rarer. Much rarer. Some were hidden inside refrigerators. Others existed in specialized medical equipment. Some could only be found in expensive industrial technology. The costs started rising. The searches became harder. And then came the real problem: radioactive elements. Suddenly, this wasn't a scavenger hunt anymore. It was a wall. Certain elements decay so quickly that they practically vanish after being created. Others exist only in tiny quantities on Earth. Some have been produced only inside laboratories. What happens next changes everything. Because I realized something nobody had mentioned. Maybe the challenge wasn't difficult because I lacked money. Maybe it was difficult because some elements were never meant to be collected at all. And that's when the entire mission started falling apart. The final rows of the periodic table felt less like science and more like science fiction. Some elements exist for only fractions of a second. Others are created atom by atom inside nuclear facilities. A few are so unstable that by the time you find them, they're already disappearing. The closer I got to the end, the more obvious the truth became. Nobody can truly collect the entire periodic table. Not me. Not you. Maybe nobody. But here's the craziest part. Even famous collections that appear complete usually aren't. Many full periodic tables contain representations rather than the actual elements themselves. Because owning some of the real ones would be dangerous, impractical, or outright impossible. Suddenly, the goal had changed. This wasn't about collecting everything. It was about discovering how much of the universe we can actually hold in our hands. After counting every item, the verdict arrived. Not 80. Not even close. 68. I had failed the challenge. The sandwich was waiting. The punishment was unavoidable. But something unexpected happened. Despite losing, the experiment revealed something far bigger. Out of 118 known elements, I managed to track down 68 while staying under budget. That means most of the building blocks of reality are hiding in plain sight around us every single day. Yet the remaining elements remain locked away in reactors, laboratories, or moments so brief they almost don't exist. And that's the mystery that stayed with me. The periodic table looks complete, neat, organized, finished. But is it really? Or are there still secrets hidden inside those tiny boxes that we haven't discovered yet? Because if scientists once predicted missing elements before they existed,